Hi, in this chapter we are going to learn about the whole circle bearing and reduced bearing. Before coming to this whole circle bearing and reduced bearing, we should know some prerequisites, some basic knowledge. So first I'll jump into that. The first thing is, if you come to the tracing the land survey plan in AutoCAD, you know the land survey plan is produced by land surveyor. So normally we get the land survey plan in a sheet of paper. As we discussed earlier, within the land survey plan, if you have multiple lots, we may be interested in one of the land. The idea is how to take this particular shape of the land in a particular area into the AutoCAD and for further development. Now, always we don't get the land survey plan like this. Sometimes from the surveyor or maybe a civil engineer, sometimes we get the data in other mathematical formats. For example, like this, coordinates, we can find east values and north values. Sometimes length of a line is given with the angle value. So here it says WCB, whole circle bearing. DMS means degree, minute, seconds. And then sometimes the data is given something like this. Or what it is, say north 73 degree, 44 minutes, 45 seconds, east, and the distance is 75 feet. Now, as a CAD draftsman, you should be able to deal with all of these things. Now, straight away, I don't like to jump into AutoCAD without understanding these things properly. So first what I'll do is, before getting to the AutoCAD, we should understand some terminologies. So that will do step by step. Now, the first thing is we should understand what is coordinate system. The coordinate system is none other than locating the position of points mathematically. We can say mathematically locating the position of a point with respect to a known point. Here, with respect to known point means 0, 0. That means this origin point. From the origin point, where is the point? Okay. For that, we use what? Two axes. Here you have a horizontal line, x-axis, and y-axis. Now, what is the location of this point? First, we can walk along the x-axis 5 units, 10 units, 11, 12 units. So that is 12, and along y-axis 1, 2, 3, 4, 5. So if you define the position of point using two lengths, two lines x and y, we say that coordinate system as Cartesian coordinate system. Cartesian coordinate system. Now the same point, if you define using one distance and one angle, we say that as polar coordinate system. So here we define the same point using one angle and one distance. Here the angle is measured from the x-axis anti-clockwise and it is marked as theta. Now this is the summary of coordinate system. Then when you are coming to the angle, we measure in degree, minutes and seconds. For example, here you can see an angle called theta. The angle of this line is theta. The theta is measured from x-axis anti-clockwise. Normally in mathematics or by default in AutoCAD, the angle is measured from the x-axis anti-clockwise. Now if you keep on increase this angle all the way up to here, that is 90 degree, and all the way up to here 180 and 270 and 360 is the full angle. Now if I take one of the angle out, example theta 1, it is obvious the theta 1 angle is more than 90 degree and less than 180 degree, and it is measured from the x-axis anti-clockwise. Now for example, if I say theta 1 in DMS, degree, minute, seconds, it is 130 degree, 34 minutes and 27 seconds. Now this is something like we say time 1 hour and 30 minutes. That is the hour and minute representation of the time. We can also say the same time 1 hour 30 minutes equal to 1.5 hours. We say that is decimal hours. Likewise, here we can also say this degree, minute, second representation in decimal degrees, like 130.5741667 degrees. Okay, that's all about the angle. Now we can come to the topic of whole circle bearing and reduced bearing. I quickly recall the previous one. The theta I told we measure from the x-axis anti-clockwise. Now in same fashion, if you measure the angle from north clockwise, we say whole circle bearing. So whole circle bearing is none other than you're measuring the angle of a line from the north clockwise. For example, if you want to measure the angle of this line, we measure from north clockwise. That is the angle highlighted in red color. Now, what is the angle of this one? Again from north clockwise. Now, what is the angle of this line? We measure from the north clockwise. And this angle from north clockwise. So if you measure the angle from north clockwise, that is whole circle bearing. Now we'll jump into reduced bearing. What is reduced bearing? Means we measure the angle from north to south line. That means we can simply say we measure the angle from north or south. For example, if you want to measure the angle of this line, we can say simply 60 degree. But 60 degree from which direction? That is very important. We can say from north 60 degree to east. We say north to east 60 degree. And this angle we can say north to west 60 degree. And here we have two angles. This one is 30 degree, south to east 30 degree, and this one south to west 25 degrees. Now that's all about the whole circle bearing and the reduced bearing. Now if I come back to the same first slide again, now we can understand better. See, the land surveyor is producing the land survey plan, and we should be able to deal with that, how to scan and take into AutoCAD and proceed with the drawing. Now sometime we'll give the coordinates, for example like this, meter east and meter north. That means 500 point something meter east, 593.71 something meter north. These are XY values, east and north values. So you have two distances. We say what? Coordinate system. And then there are certain instances we get the length of a line and then the angle, the whole circle bearing. So this angle is what? All the way measured from the north clockwise. And sometime you'll get the information, the data like this. This is called as reduced bearing. See, from the north 73 degree, 44 minutes, 45 seconds east. The length of the line is 75 feet. Now, whatever the format, whatever the way, doesn't matter. If you get a data, you should be able to convert that into drawing in AutoCAD. I hope now you have enough knowledge. Okay, now let's consider if you get these four types of data formats, how to deal with the AutoCAD. That's what we are going to learn from the next video onwards.